G'day everyone and welcome back to my channel. So I've got a couple of things to mention quickly. One, I've attached a wire to signal ground just because I need a reference point off the plus 15 volt rail and I need a reference point off signal ground and a ground reference. So 3 spots to hook up one side of my meter. The other thing I noticed was that in the last video, I feel so silly about this, really. Like, purely, I really feel like an idiot. I was trying to work out why there was voltage here, and I was trying to work out if it was coming back from here or leaking from the capacitor or something. What I didn't notice was that whilst this these cats. My apologies. So whilst those are NPNs, those are PNPs, and the current's just flowing straight out the base because it's supposed to. I don't know how I didn't spot that. I was watching over the last bit of the video just to remind myself today where to pick up from, other than like my notes and what I remember. You know, just in case there's something I missed, and I spotted that and I just started laughing at myself. So anyway, it is what it is. With that in mind, I guess I've got a little bit more to look at because I was actually thinking in like the complete reverse. I was correct here where I was measuring everything, but once I got back to here, I don't know what I was thinking. Anyways, they're PNP, not NPN, so I'll re-go over this and try and make sense of it. The other thing I thought of was, I think I might have mentioned this in the last video, I'm not sure. I didn't rewatch the whole thing, and honestly it went on for so many days. I didn't watch over the whole lot when I was splicing it together. I really just wanted to hurry up and get it up. I've not had much time like in the last week to get to do work on this, and I'm just trying to get the amp finished and get the video finished. But anyway, I was wondering if there's a current flow path between that transistor that goes to the mute circuit and the other one on the other channel, and if that's how, like that's the correlation between the two channels. And it quite possibly could be. Let me just show you what I found. So I'll just power this up. What was it? Q109. And let me just get my wits about me. I can't remember what it was referenced to, and I've literally just walked in here and started for the day. I'm just going to pause the video and just have a stare at the schematic for a minute. Okay, yeah, it was the plus 15 volt rail. So Q109 is the bot. You remember how I said the mute circuit goes to those transistors that go from the positive rail to the positive 15 volt rail to that diff pair, and if mute's enabled, that transistor is essentially like pulled down, or pulled up. It's a PNP. It's turned off. It's open. If the mute's off, it's on, and the diff pair has current flowing through it. Well, Q109 is the, let's call it mute switch transistor for that side of the amp, not this side. Incidentally, Q109 is the one that's got the 3.9 volt Zener diode on it. Q110 is the one that I was looking at in the last video. Anyway, I just want to show you something I found that's different between Q110 and Q109. So Q110, wait, where's Q109 gone? Oh, it's in this box, right. I'll start with Q109 because it'll make more sense. So we've got 3.294 on either the collector or the emitter. 3.961 on the base and 3.282 on either the collector or the emitter. Q110, we've got our 3.9 volts on the base, but when we look at the collector and the emitter, hold on, let me just look at the schematic for a second so I can tell you what's what. Looking at that, that's not going to tell me actually. Never mind. Well, anyway, here's the thing. Was it this one? Yeah. Yeah, this one. You got 3.9 and 3.325. I know 3.325 isn't too far away from 3.282, but it is still different. But what I'm assuming is the emitter has, sorry, no, the collector, it's a PNP. What I'm assuming is the collector that goes to the diff pair, that's got 6.8 volts on it. So one has 3.294 volts on it, the other one has 6.8. It just keeps getting weirder because I would think that the side of the amp that's got the 6.8 volts on it, like that there's a problem there. But incidentally, that's the side of the amp that when it's powered up off the plus minus 15 has less offset voltage on the output. And honestly, the offset voltage on the output when it's not powered up from the plus minus 15 and the output stage is just sitting there not biased, that little bit of offset voltage difference between the two channels, it could just be like, you know, leakage, all sorts of things, because the stage isn't biased, like floating bases and stuff like that. It might not actually even be an indication that there is actually something on the right channel. I'm just hoping, you know what I mean? But yeah, I'll be honest with you, at this point in time, I'm still quite confused as to what channel the problem's on, or if it's a problem on both channels. It's got me. But like I said, now I've realised that those transistors are in fact PNPs, not NPNs. I'm going to have a look at that now. That's the very next thing I'm going to do. Have a look at it, work out how it should be working. I'm sure that's why yesterday I was getting so confused staring at it and it didn't make any sense to me because, well, I was imagining two of the transistors were inverted polarity. Anyway, so I'll be back in a moment after I've had a better look at it, and then we'll start taking some measurements from that first diff pair and see if we can find anything. I get the feeling that we might end up having to go and have a look on the other channel too. I mean, at this point in time, I don't know if there's literally two problems on, you know, one on each channel, or like I said, if it's one problem that's somehow tied between the two channels, which, you know, that's very well possible because if something was going on crazy in this current path here between the differential pair and what's going on down there, or same thing for the other amplifier, and excessive current got pulled through this string, I'm sure that could affect the other channel simultaneously. Not in normal operating conditions, I'm saying with something gone completely apeshit sour. So I'm going to have a quick look at that now, that diff pair in that section, and work out if that is actually something that can happen or no, and keep looking elsewhere. So I'll be back in a moment, but we still have to look at that diff pair anyway. So either way, I'll be back in a moment. Okay, I've come up with a decision. Seeing as, I'll just show you in the schematic. I've got to remember to lock the image too. I've only just discovered that as of yesterday, so I'll get used to it. These two transistors over here they're controlled from this mute line. Now, obviously, I've had this thing powered up with this cable plugged in and unplugged, so whether this transistor's turned on or turned off, I'll just take one quick test. I'll unplug the cable and I'll just verify that these are both off. I just want to test the differences in... Oh, that's not going to work because it won't be powered. Yeah, I'm going to take these two transistors out, Q109 and Q110. I'm just going to have a quick think about this first. Make sure that's not going to do something bad to the output. But what I want to do, excuse me, is I want to isolate this path between the two stages. And I want to see then what measurements I get then. Just let me lock that. Okay, that's better. Wish I discovered that a long time ago. Anyway, so I want to work out if I can do that and then measure the second diff pair and first diff pair on each side and see, you know, does one side look normal and the other side's all jacked up, or are they both still jacked up? Basically is what I'm getting at. Alright, I'm just going to stare at the schematic and see if that's a viable idea. Alright, yes I can. I can take them out because they are normally just biased off with a 4.7k pull up, they're PNPs, and the mute rail biases them on with a positive voltage, and current can't flow, say back, oh I've got to unlock that, back like this anywhere, because obviously the other transistor will be pulled out, so it can't, you know, it can't flow back into this circuit. So I can take them both out. So I'm going to do that now. I'm just going to do it with the soldering iron because I don't want to take hot air near that connector. I already took it near the back of it and it started to melt it a little bit. Don't want to damage it. Excuse me. Soldering iron tip's just a little bit dirty, my apologies. I was turning the temperature up to like 370 because these boards are a bit thicker than some other types of boards, and also the circuit board material. Some boards soak up heat faster. That and how thick your plane is, like ground plane or traces, are two big factors. Where did I put my tweezers? Oh. Just put that there. And Q110. Alright, they're cleaned up, ready to go back on. Alright, let's get back to measuring. So the first diff pair, did I want to measure that against? One moment. The first diff pair the second diff pair, this pair, I want to measure that against the ground rail. Alright. Now things are looking different, aren't they? Okay, what's on this side? That doesn't make sense. What am I missing here? Oh, let me just pause whilst I have a look at the schematic. Alright, well, I got curious because there's 4.9 volts on the collector of that one, and on this channel, just for reference, the transistor I'm talking about is the one on the left side that's got the VBE multiplier transistor in line with it. Because that voltage difference, I started looking back and just have a look at this. So one side of this op amp, the output of it has got this voltage on it that just slowly falls, which is obviously the capacitor that's in between its output and the base junction of the first diff pair. Look at this. This is the other side of it. The other output. Yeah, that's really weird. I just looked at that a minute ago and it was just sitting flat on 20 volts. Yeah. What on earth made that discharge? Surely not me touching the other side. Yeah, what? Okay, that's odd. Don't tell me the op amp analyzer JFETs are fried. I still don't see how that would be causing this sort of a problem, because the output of the op amp is capacitively coupled, unless those capacitors are leaky. I was starting to think, honestly, before I go and waste a whole bunch of time pulling off all these little transistors and individually testing them for leakage and crap like that, I think I might actually have a quick look at, are they electrolytics? Hold on. C114. Yes. Okay. That's a bit of a possibility. That won't surprise me either, because it was always strange to me how you could turn it on, you could fire the power button and eventually it would let you turn it on. Like before I pulled it apart, as it originally was. But it was like something was charging up or discharging. Let me just have a look at the schematic and, oh no, that's pointless. I was just going to say, let me have a look at the schematic and see, no, actually there is a path, hold on. We might be onto something. So, there is this path here that current can flow out this base, back down signal ground, and then there's this little biasing arrangement and these JFETs. That could, if something's wrong here, you would see a voltage on the output of the op amp. But to be clear, the voltage is here. I'm not looking here on this side of the capacitor. So that voltage is being supplied by the op amp. So that's a problem. Let me just work out what side, like what channel that is that's got that. Not the side with the falling voltage, it just looks like a series cap between two DC decoupled stages, but this side with the voltage just on it. So that is C109R110. C109. Yep, it's this channel. The one that I initially thought had something wrong with it. We might finally be getting somewhere now. After all this time. I don't know what to look at first. Caps, op amp, JFETs. I'm seriously interested in this area here. I think I might have just found the source of the problem. C114 and C113, they've got to be the two coupling caps. Yep, C114, C113. They're the coupling caps between the output of the op amp and the first diff pair. I'm going to take these out first. I just want to see if they're leaky, and I'm going to take the op amp out and I'm going to put it on a what do you call, breakout board, a little homemade breakout board, and see what I get. I'll stop the video here because I've got to wait for my desoldering gun to warm up. Yeah, I'll come back when I've got the caps off, and then we'll check them, and then we'll take the op amp off. So I know this has got absolutely nothing to do with leakage, but these are 100 microfarad capacitors. It's not looking very good. Had a bad connection. These caps are not reading at all. Not normally. They're screwed. That's only at 100 Hertz. And it's coming in at 56.9. With an ESR of 4.7 ohms. The other one's got half the ESR and a quarter more capacitance. Again at 100 Hertz. These are 16 volt caps. I'm curious if they're leaking current. I'll just pause the video whilst I set up a few things. Okay, so I've got 18 volts going through the cap. It's a 16 volt cap, so that's within the tolerance rating, but I've just got it on the high side just to make sure, you know. And I've got this in series, like so. I'm just gonna dial back to 50 microamp range. And what do we have here? Let me just put this flat and I'll tell you exactly what we've got. We've got 15 microamps of leakage. I'm just going to dial that back down 2 volts. We've got, oh no, it's slowly climbing again. It's climbing very slowly, but it's going to eventually be at 10 microamps. You see, it's just slowly climbing, but it is climbing. I don't know what the acceptable leakage is. I'm just going to have a quick look at a data sheet for this cap. It's an Ichicon VRM series. I'm just going to have a quick look up the data sheet just for my own curiosity and for everyone else's curiosity. It looks like I might not be condemning these capacitors after all, because it's been about a minute or two now. Basically, I just looked at that and then turned back around, and this has dropped down to 1, 2, 3 microamps, which is, I've got the data sheet here for the VRM, and this is the correct data sheet for the 16 volt 100 microfarad VRM series, and it actually says that after a minute's application of rated voltage leakage current, leakage current is not more than 0.03 CV or 4 microamps, whichever is greater. After 2 minutes of application of rated voltage, leakage current is not more than 0.01 CV or 3 UA, whichever is greater. And, well, yeah, it's done that. So I still think they're actually a little bit on the dinky side. I mean, obviously the ESR is a little bit high. The capacitance is low, especially on one of them. And they're a little bit leaky. So I'm going to change them. But I was getting a lot more concerned because I was sitting there thinking, well, if it's that bad, how bad's everything else, you know? But I'm still going to recap the entire board just to feel comfortable, and I'll do the power supply too. We'll test all the bigger caps, but I'm talking about this particular series, these small black VRM series. I know that this brown series that's on the power supply, I've come across plenty of them and I've had no trouble with them. So I wouldn't be surprised if they're good, but then at the same time, I wouldn't be surprised if they're worn because they're on the secondary of a switching supply. So they're subject to high frequency ripples. So yeah, could be doing a little bit of recapping. I think that's all I'm going to do now. I'm still going to take this off the board and put it on a breakout board and test it. But yeah, I'm going to get that done now. I'm going to pull off a few caps. Or not a few, I'm going to pull off all the caps that are this VRM series and I'm going to change them. Whoops. And yeah, we'll go from there. We'll take the op amp off then, put it on a little breakout board, power it up, have a look at what's coming out its outputs. Obviously whilst referencing its inputs appropriately. And we'll see if it flips states, maintains zero, if it's got any offset, you know. We'll see what the op amp's doing. So I'll get set up. Well, I'll do the caps first and then I'll get set up for the op amp. Alright, after having a good look at the schematic, I don't think I'm actually going to do such a big capacitor job, and here's the reason why. All these other capacitors are either holding a rail voltage like these ones, or they are on the bias network like these two that just hold the VBE multiplier voltage across them. And then these other few down here that are actually coupling capacitors, there's only 4, and they're 0.22s and 0.47s, I think. Oh no, we've got a couple of 10 microfarads here and 2.2, sorry. 10, 2.2, so there'll be what, 4 10s and 2 2.2s. Why can't I? Hey guys, what? Oh, wrong cap. Yeah, 2.2, 2.2. Okay, so 200s, 2.2s, 4 10s. Actually, what are those 10s doing? Oh, the 10s are just decoupling power rail caps too. So, you know what? I'm just going to change the 2.2s because they're in between differential pairs for coupling purposes. What's C142? Let me just find this cap on the schematic. Alright, I'm not going to lie, I didn't spot them in the brief look I had in the schematic, but they're 10 microfarads, I don't think they're coupling. So, I'm just going to change the... Well, they could be, but because... I mean, it depends on the impedance at the stage you're coupling as to what capacitance you're going to use to let a given frequency through. So I guess, yeah, I'm going to go do my due diligence and actually find them. Okay, I found them, and they're not they're not coupling capacitors. They're decoupling the power rails for a couple of transistors. The push pull that decouples the power to the push pull for the power rail switching FETs. All right, so with that being said, I'm going to do the 2.2s. Interestingly enough, though, in the schematic, I keep finding these 0.047s. Which is confusing the crap out of me because I haven't seen a single 0.047. One minute, let me just make sure they're electrolytics. Let me find them again. Okay, I found them, they're not electrolytics, it's these. All good. Alright, well, I'm going to change those two, so I'll do the other two first because they're different values, just so there's no chance of me screwing them up. I mean, it's not like it can go that bad because I've got schematic, but you know, it's always better if you only change things once than twice. So I'll get these caps changed and then I'll come back and we'll take this off and we'll have a look at it. Just to show you These are the capacitors that I buy from J-Car, which is one of my sources of capacitor. And this is one of the brands that I get from there. They've got different brands. What's going on? I don't even know what it is, but I've always had good luck with these caps. They've never been bad. That's what it comes in. Oops. That's what it comes in at. 16 volt, 100 microfarad. That's an order of magnitude better than what just came off of there. So I just wanted to show that. And these are the other capacitors. Just for reference, the 3 different brands I commonly find at J-Car are those TI green low ESR caps that I use, the branded TI, those ones I just showed you, the Yamaha, and these suntan branded ones. And I've had good results with all of them, I can say that. I'll just show you guys what these come in at. So that's a 2.2 microfarad at 100 hertz, and it comes in at 12.2 ohms and 2.110. I'll measure the ones that are on there just to have a look at them, just for shits and gigs when I take them out. Incidentally, these are at 63 volt. Actually, I do want to have a look at these because I want to see how the ESR compares to those ones. I might end up having a look around my stock for something a little bit better if the ESR is too high. And that's the original one. It's got 15.4 ohms, but it does come in at 2.2 microfarads. And I'm giving them the best possible chance because I've got it at 100 hertz. Not that there's really much of a difference between 100 and 120 hertz, but if you look at the data sheet, almost every electrolytic capacitor is spec'd at 120 hertz. But anyway, that's neither here nor there. So, okay, I'm happy with my selection. So that's what's going in there. I'll take the other 2.2 out now. And I'll get to fitting these. Then I'll come back. Alright, that's the new coupling capacitors installed. So, I'm an idiot. You know what I should have done? I should have taken the bloody op amp off first. That's alright. I'm just going to take it off with the soldering iron, I think. Yeah. I'll take it off with the soldering iron. I've got to go out now, so I'm going to leave the video here and come back, but to you guys it will only seem like a second. So something just came to mind. I haven't taken this off yet. I haven't done this yet. I was just sitting there thinking, and something came to mind. Those 2 transistors that the mute switches, that the mute line uses as a switch to the diff pair, the first diff pair, one of them had, I think it was 6.8 volts or something like that on the collector, and the other one had the expected 3.9. That tells me that the diff pair underneath that one transistor that's got the higher voltage on its collector is sinking basically no current, because if there was enough current flowing through it, the transistor would be, you'd just see the Zener voltage on its collector, if that makes sense. But because the current path below it's so high in resistance, or open, or whatever you want to think of it as, that's why I'm seeing a higher voltage, I think. So I'm going to have to come back to that and have a look at it. And whilst those transistors are off the board, I'll test them too. That's probably a good idea. They are the only 2 parts that are actually, what do you call it? Go between the 2 channels. Well, other than the op amp, but that's the thing, like I pointed out, the op amp's capacitively coupled into the diff pairs. So the only thing that's DC coupled between the 2 channels is these 2 transistors. So I think it's probably worth me soldering those to a breakout board, or just soldering 3 little bits of wire to them or something and sticking them on the tester as well. So yeah, just something that came to mind. So I'll take that off and we'll test all 3 things. Alright, I got the breakout boards assembled and I just want to see if I can get away with something a little sneaky. Yeah, I reckon I can. I don't have to solder 3 bits of resistor leg or something onto this then. That works quite well actually. Okay. Great. Okay. Talk about matched. Quite well matched. Yes, very well matched. Not that they need to be matched for what they're doing. Oh, I don't see anything wrong here. What was the VC set on that? Yeah, exactly the same. Well, they're good. Just move those back. Alright, I'll make up a test circuit for this now. I got a funny feeling that there's something wrong with that. Just, I don't know, just a gut feeling. We'll see. Well, that just turned out to be very, what's the word? Uneventful? No. A waste of time. So, this is the first side of the op amp, just sitting there as a voltage follower, as expected. Oh, I've got 15 volts across here, by the way. These are all 10k resistors. Positive side tied to false ground. I'll just leave that there. The wire's a little bit too on this. It's a little bit too. It's not thick. It's just it's not like a silicon cable, so it's a bit stiff. These are just leads I made myself. Tell me this side works too. Alright, input offset voltage is the only other thing I'm going to bother looking at quickly. But there was definitely odd voltages on the output of this in circuit. So I'm going to have to look at that. Seems a bit high. Oh, that's fine. So I just wasted my time. Alright, well I guess those parts can go back in. I'm going to do a bit of thinking first because the fact that the output voltages on the op amp were completely different. I can't even remember what they were. I'm going to have to go back in the video, but well, that can only be one of two things. Something to do with that the two JFETs and there's three resistors in series on the negative input and a couple JFETs that go in between the center point, the two center points of those three series resistors and the signal ground rail. You've seen it in the diagram. That there. Well, the only thing that could be wrong is something here or voltage coming back. You know, like there's no other way for that voltage to be there. So I'm just gonna finish pulling this back apart. I'll pause the video. I'm gonna have a stare at the schematic with this new information and have a rethink. Because, yeah, I'm honestly quite surprised. I really thought when I saw that, I was like, yes, it's the op amp. No. Oh well. I'll be back in a sec. As I was packing these resistors up, something came to mind. A video I'm going to be doing coming up. There's a few things I'm just going to buy because I just can't be bothered wasting the time building it when I've got other things to do. But one thing I am going to build is just an op amp tester, and I don't mean one of those things that just is a square wave oscillator that blinks a couple of LEDs. I'm talking about a proper board where you can measure all the different parameters. You know, I can put a function generator on the input, hook my scope up to the output. I can measure offset voltage on the output, input offset voltage, everything. Like I want to make up some sort of test board. So that's a project that's coming up in the future. Just putting it out there. Because too often I find myself having to test op amps, and depending on what the op amp's in and what type of op amp it is, what it's doing, I'm testing for different things. So, yeah. I mean, usually I'm testing for the same sort of things, but there's always that niche application, like you're trying to design some super low distortion oscillator or some project like that, and you want to check the performance of like you got 10 of the same op amp and you want to check them all against each other, just little niches like that. I want a board that can just do everything, so that whatever question I have, I can answer it. So that's something I'm going to design and come up with in the future. I've certainly got way more important things to be doing at the moment, so it's not going to be too soon, but it will be in the future. Alright, I know what I'm going to do first. First thing I'm going to do, before I put back the two transistors that essentially take it out of mute and turn it on, and before I put back the op amp, I want to see what voltages there are, like what's going on without those parts there, like what's on the inputs to the op amp, what those JFETs are doing, what's on the output of the op amp without the op amp there, so what's being backfed. I want to see all these things now. So that's exactly what we're going to look at. I'll do all this off camera. Alright, so for this, we're going to be looking in between signal ground and the op amp inputs first, because I just want to see what voltage is there. Okay, so on the negative input of, well, the side you can see I'm on, there's that there, 1.4 volts. What does that go back to? Okay, that's actually a really good thing that that line's got nothing on it. Oh, what am I saying? Sorry, that was the positive input, wasn't it? Yeah. Alright, so the one that goes back to those JFETs, the non-inverting input, inverting input, what's that doing? Oh, that's interesting. That's very interesting. So, it's a problem with the JFETs on one side? Just look at that. That's what I would expect to see on the inputs, nothing. Well, reference to signal ground. So where's this 1.4 volts coming from? I think we've finally found the source of the problem. Alright. I think what I'll do, because I need to... The thing that's really hard about this is I can look on the screen and see the circuit diagram, but trying to find where trace is actually going here. It's, yeah, a multi-layer board. Oh, no, it's 2 layers. Wait a minute. No, that's got more than 2 layers, I think. Oh no, 2 layers. Alright, no, so I can just look underneath if I get stuck. Okay, cool. That's good to know. I thought there was more layers. How do I know what this side... Alright, C109. What's that one? Ah, okay. C109 is this side of the amp. I mean, the C109's the cap, the negative feedback cap on the side of the op amp that's for this side of the amplifier is what I'm trying to get at. So where this 1.4 volts is on the negative input, that is well, I think I can confidently say it's not coming back through the capacitor from the negative feedback, because that's a 22 picofarad film cap, you know. Oh yeah, but there's the resistors, I didn't think about that. No, there's another capacitor before that goes back to a 560 ohm and then 560 ohm resistor and signal ground. Sorry. So if voltage was going to go back through here, it still couldn't flow back through here. Alright. I'm just going to pause and have another think about this. I think I'm just going to take off one more thing. Just one more component. Either that resistor or that resistor. Oh wait, what am I saying? That's on the output. I was on the signal ground rail, wasn't I? Oh, there's nowhere I can break that line, isn't there? No. Damn. Oh, that would be so easy. Alright, let me think some more. You know what? I've been working on this for a little bit today. I need a break. I think this video has been getting on a little bit too, so I think I'm just going to leave it here for now. Have a break and then come back to it, because it's just honestly starting to shit me. It's not good. I like to keep my work fun. If it's getting annoying, it's not fun. I guess when I come back, we're going to work out where this 1.4 volts is coming from. Is it coming upstream from the diff pair, and that transistor that's in the max power adjust section. So is it coming from, oh, it could only be coming from here or here, or is it something to do with those? So I haven't checked D138 either, but that's where we'll be looking when I come back, because certainly this is where the problem is, and it looks like my gun instinct was right that it is something on this channel. I have a funny feeling I know what's going on now, but I could still be wrong, so I don't want to be an idiot. But I think what's happening is that offset voltage is getting amplified a bit, fed through, trying to bias just the NPN side on, and then because the diff pair, the first diff pair of the two stages is completely screwed up with its bias voltage, it's trying to pull current, you know, those two transistors that the mute line goes to. I think there's current flowing through there that's affecting the other channel. I could be completely wrong, but I'm trying to imagine how this fault can affect both channels. That's the only thing I can come up with. So, you know, that's the other good thing about taking a break. I find a lot of the time when I'm sitting there relaxing, or I'm having something to eat or whatever, I'll start thinking about it, or I'll go back and watch one of my own videos sometimes too, or just a section of the video when I'm thinking about like that section. And the second time I, you know, look at it or think about it, something else will come to mind, and you know, so yeah, let's hope that happens. Anyways, that's all for now. Thanks for watching. Please like and subscribe, and I'll see you all in the next one.